Hi, I hope you're doing great. Today we will discuss a new topic that's called implicit differentiation. So far you most likely have already worked with the explicit function. So an explicit function, it's like the normal type where you have a y at one side and you have the other side expressed in terms of x's. So in this type of cases, you just differentiate as normal. However, if you have an implicit function in which you have x's and y's combined at one side of the equation, you have to use another type of steps. And yes, you might be thinking, why don't I just solve for y and leave the other side alone with x's? You could do that, but I promise that the procedure is way larger if you do that step. It's much easier to follow the implicit differentiation steps, which I will show you just now. The steps for this type of procedure simply include this. First, differentiate both sides of the equation with respect to x. Next, you have to add a dy dx whenever you differentiate a y term, and finally, you solve for dy dx. Now, you must be wondering, why do I need to add a dy dx? Well, you have to think of it as if it were the chain rule. So, whenever you encounter a y, try to imagine that that y has inside, or it represents something expressed in x, okay? So, say you have, for instance, y squared. So when you find the derivative of this, simply apply the power rule, that will be 2y, and then you have to multiply by the derivative of y. So it's the chain rule. And the derivative of y is dy dx. Say you have dy dx of 2x squared plus xy squared equals to 1. So the first step is simply to find the derivative of each term on both sides of the equation. So you know that the derivative of 2x squared is simply 4x due to the power rule. Then in here you have x times y squared, which is a product. So you have to apply the product rule. The product rule simply means the first one, which is in this case x, times the derivative of the second one. And the derivative of y squared is 2y. However, since you're finding the derivative of a y term, you must add dy dx. Remember, this is really important, do not forget that. Then you add up that to the derivative of the first term. In this case, x is 1, so 1 times y squared. In this case, y squared does not have a dy dx because you're not finding the derivative of that, okay? And that will be equal to the derivative of 1, which is a constant, so it will be 0. Next step, you have to solve for dy dx. So in this case, all you have to do first is move everything to the other side. In this case, the y squared and the 4x. So let's copy first. I'm gonna order this to so it can look nicer. 2xy, and then you have dy over dx is equal to, and you move everything to the other side, so that will be negative 4x minus y squared. Next step is simply to move this 2xy to the other side dividing, so simply write dy over dx is equal to, you factor out this negative just to make it look better, and then you divide that by 2xy. So this will be the answer, or the derivative to this function. Now let's do one last example. Say you have dy dx xy plus 2y equals to 3. So, as always, first you find the derivative of both sides of the equation. So again, here you have a product, so you apply the product rule. First, the first term times the derivative of the second one. So we have here a y the derivative of y is 1, and you multiply that by dy dx. So add a dy dx. Then it will be the derivative of the first term, in this case it will be 1 times y. So y. Remember, you don't add a dy dx to this y because this y is not the derivative. You're simply copying the same term. And then simply find the derivative of 2y, which is 2. In this case, you do add the dy dx because you have just find the derivative of a y term. And then that will be equal to 0 because 3 is a constant and the derivative of a constant is 0. Now, all you have to do is move this y to the other side and solve for dy dx. Now, as you can see, you have two terms with dy dx. So what we can do in this case is to factor out that dy dx. So let's do that. That will be dy dx times x plus 2. And that will be equal to 0 minus y. That will be equal to negative y. And then simply solve for dy dx. So that will be dy dx is equal to negative y over x plus 2. And that is the derivative of this function.